We're back. Hey, you know there are lots of different ways to crush a soda can. With your foot, with your hands, on your head, using the reducing spell, reducto. Well, there's actually a way in which you can crush it with an implosion experiment. Just wait until the can goes pop, and then we'll see who has nerves of steel. We will need an empty soda can, search your cycling bin or start drinking, an alcohol lamp and a tripod, cooking tongs, some cold water. Make sure the soda can is clean. Fill a bowl with cold water. The colder, the better. Add 1 generous tablespoon of water to the empty soda can, just enough to cover the bottom of the can. Light your alcohol burner. Hold the can. Place the can on the tripod with a lighted alcohol lamp underneath. When you hear the bubbling sound of the water boiling, you'll see water vapor rising from the can. Continue heating the can for 1 more minute. It is important to think through this next part before you do it. Here's what's going to happen. You're going to use the tongs to lift the can off the burner, turn it upside down, and plunge the mouth of the can down into the bowl of water. Don't hesitate, just do it. Are you ready? Okay, then let's do it. There you go. Our imploding can. Kids, remember, this is the proper way of putting out the flame of the alcohol burner. Safe and sound. Now, here's our imploding can. Here's the real scoop on the science of the imploding can. Before heating, the can was filled with water and air. By boiling the water changed states from a liquid to a gas state. This gas is called water vapor. The water vapor pushed the air that was originally inside the can out into the atmosphere. When the can was turned upside down and placed in the water vapor condensed and turned back into the water. Water molecules in the liquid state are many times closer together than molecules in the gas state. All the water vapor that filled up inside of the can turned into only a drop or 2 of liquid, which took up much less space. This small amount of water cannot exert much pressure on the inside walls of the can, so the pressure of the air pushing from the outside of the can is great enough to crush it. The sudden collapsing of an object toward its center is called an implosion. Nature wants things to be in a state of equilibrium or balance. To make the internal pressure of the can balance with the external pressure of the can implodes. Hey, air pressure is powerful. One more thing, if you watch very closely when you turn the can upside down, you'll see that the cold water into the bowl shoots up into the can. This is similar to what happens when you drink from a straw. Though we say we are sucking liquid up through the straw, we really aren't. Outside air pressure is pushing down on the surface of the liquid. When you reduce pressure in your mouth, that sucking action, the outside pressure is greater than the pressure inside your mouth, and soda shoots through the straw and into our mouths. The same thing is true with the can. The force applied downward onto the cold water pushes the water up into the can. You know you can light a candle with another candle, but if you blow one of them out, did you know you can relight it from a distance? In this trick, you blow out a candle and relight it by causing flame to travel along a path of smoke. No need to mutter incendio. Just follow these very simple steps. Light a candle. Have a second source of flame ready, such as another candle or another matchstick or a lighter. Blow out the candle and immediately place the other flame into the smoke. The flame will travel down the smoke and will relight your candle. This fire trick is based on how candles work. When you light a candle, the heat from the flame vaporizes the candle wax. When you blow the candle out, vaporized wax briefly remains in the air. If you apply a heat source quickly enough, you can ignite the wax and use that reaction to relight the wick of the candle. Here's one last flaming experiment before we bid adieu. Would you believe me if I tell you that you could extinguish a flame just by placing it partway into a graduated cylinder? What if I tell you you could relight the fire without a match or lighter? Both propositions seem magical, if not downright impossible. With the flame light relight experiment, however, you'll see how a few household items can mix together and create a fire-based experience. You have to see to believe. We would need yeast and baking soda, white vinegar, hydrogen peroxide, a popsicle stick, 2 graduated cylinders or similar containers, some matchsticks, and a measuring spoon. Here's how to do it. Add a teaspoon of baking soda to 2 graduated cylinders. Add 1 teaspoon of yeast to both the graduated cylinders. Shaken, steam, and twirl the graduated cylinders to mix up the baking soda and the yeast. Add a generous splash of hydrogen peroxide to one of the graduated cylinders. In the other graduated cylinder, pour in a generous amount of white vinegar, the addition of hydrogen peroxide and vinegar to their respective cylinders creates a reaction with bubbling and fizzing in each of the cylinders. This is how you know you're on the right track. Use a match or a lighter to ignite a popsicle stick. Make sure that you have a consistent and strong flame on the popsicle stick before continuing. Now that you have it, stick the lit end of the popsicle stick down into the graduated cylinder that contains vinegar. You don't need to touch the bubbles or the liquid. The flame will extinguish. Now take the still smoking popsicle stick, placing and holding it in the cylinder that contains hydrogen peroxide. Again, no need to touch the bubbles or the liquid in the cylinder. The ember, where the flame once was, will begin to glow more intensely as it stays in the cylinder until the flame relights. Most flames require oxygen, fuel, and sufficient heat to ignite and stay lit. These three components of fire are referred to as the fire triangle or combustion triangle. Removal of any of the three components will cause the flame to extinguish or go out. In the instance of the popsicle flame, the three necessary components are present during the initial lighting of the fire. The heat generates from a separate flame or the matchsticks. The wood of the popsicle stick provides the fuel. Finally, the oxygen level present in the atmosphere is enough to sustain the flame. When you stick the flaming popsicle stick into the first graduated cylinder, it extinguishes. That means one of the three components of the fire triangle is missing. But which one? The secret lies in the bubbling mixture in the cylinder. The baking soda, also known as sodium bicarbonate, is the base. The vinegar or the acetic acid is a weak acid. When baking soda and vinegar are combined, the immediate acid-base reaction creates carbonic acid. Carbonic acid is unstable and decomposes carbon dioxide or CO2 and water or H2O. The bubbling that you see inside of the cylinder is the production of carbon dioxide gas. When you dip the popsicle stick into the cylinder, you're exposing the flame to concentrated CO2 gas. The lack of oxygen extinguishes the flame. Upon placing the popsicle stick into the second graduated cylinder, the ember begins to glow more intensely until the flame reignites. The invisible property at work is the reintroduction of oxygen or O2. The high concentration of oxygen in the cylinder makes the heat source more intense until the flame ignites again. Hydrogen peroxide or H2O2 is fairly unstable and always trying to decompose into water or H2O and oxygen or O2. When yeast is mixed with hydrogen peroxide, it acts as a catalyst to the decomposition. This creates oxygen at a much faster rate than you can see bubbling inside the graduated cylinder. Placing the partially glowing ember into the concentrated oxygen completes the fire triangle and reignites the flame. I hope you enjoyed our experiments for today. We now know magic really does exist in the realms of science. So remember, there is magic in science and there is science in magic. Have a good night, everyone. Bye-bye.